52. Yes, it's even. It ends in a 2. So 2 is a factor. Now if we add up 5 plus 2 is 7. 3 doesn't go into 7, so that's out. Ends in a 5 or 0? No. 6 has to be for 2 and 3. 3 doesn't go in there. So 9 depends on if you add the digits. 5 plus 2 is 7, so that's out. And then for 10, doesn't end in a 0. So 2 is our only factor out of those choices. All right, for 891, let's add up the digits first. So let's see, 9 plus 1 is 10, plus 8 is 18. Great. So does 2 go in there? No, because it's not even. Does 3 go in there? Yes, because 3 goes into 18. Does 5 go in there? No, because it doesn't end in 0 or 5. 6 does not go in there because it has to have 3 and 2 as a factor. 9? Yes, because 9 goes into 18. And 10? No, because it doesn't end in 0. Okay, for 4,805, let's add these digits up. 4 plus 8 is 12, plus 0 is 12, plus 5 is 17. So does it end in an even number? No. 2 is out. 3 does not go into 17. That's out. 5, yes, because it ends in 5. 6, nope, because 2 and 3, neither one goes in there. 9 does not go into 17. And by the way, if 3 is not a factor, then 9 definitely won't be a factor. And then 10, no, because it doesn't end in 0. All right, last one, let's add up these digits. 4 plus 3 is 7, plus 7 is 14, plus 6 is 20, 28, 32. Okay, now, is it an even number? Yes, this is an even number. The adding up of the digits really only affects the divisibility of 3 and 9. So does 3 go into 32? No. Does 9 go into 32? No. So 2's in, 3 out. 5, nope. 6, nope. 9, nope. 10, nope. So just 2 out of those options. Now we're going to do some prime factorization. Now you probably have done this in the past, but prime factorization is breaking down a number to its just prime factors. And prime numbers are numbers that are only divisible by that and 1, like 7. The only factors of 7 are 1 and 7. 3, 1 times 3, that's it. So 825, you can pick anything you know that goes into 825. So let's say you're like, oh, well, my divisibility rules, I know that 5 goes in there, so we're going to split it like a little tree. 5 times, let's see, 825 divided by 5. 5 goes into 8 once. We subtract 8 minus 5 is 3, bring down the 2. 5 goes into 32 6 times. And then we bring down our 5, and it goes into 25 5 times. So 825 is 5 times 165. Now here's what I like to do. As soon as I get a prime number, I circle it, so I know I'm done with that. 5 is a prime number. Nothing else goes into 5 except for 1 and 5. 165 is not. I see that, again, this ends in a 5, so we could at least divide it by 5. 165 divided by 5. 5 goes into 16 3 times. Bring down our 5. And 5 goes into 15 3 times. So 5 times 33. 5 is prime, so I'm done with that. Then we look at 33, and you're like, oh, well, what goes into 33? And you're like, oh, snap. 3 goes in there. It's 3 times 11. 3 is prime, and 11 is prime. So we've got it down to the bare bones, all the prime factors. So now we're just going to write it. You always write it with your smallest number first. Let me stop this timer real quick. Our smallest number is 3, so we write that first. Then our next smallest one is 5. Now we have 2 5s there. So we have to write 5 to the second power. And then we have the 11. So this would be your final answer. That's how you write with prime factorization. We'll practice a bunch more here.